and welcome to Dr. G's Technique of the Week, Geometry Edition.
Identifying some polyhedra and other three-dimensional solids. So what is a polyhedron? A polyhedron is a three-dimensional solid whose faces, or more colloquially sides, are polygons. And what's a polygon? A polygon is a plane or two-dimensional shape with straight sides. So squares and triangles and rectangles, those are polygons. What do you think? Is a circle a polygon? A circle is not a polygon since it doesn't have straight sides. Moving back to polyhedra, an example of a polyhedron would be this Kleenex box, since all of its faces or sides are flat and they're polygons with straight sides.
One way that we can characterize polyhedra is by counting their faces, edges, and vertices, and describing the shape of their faces. Consider this cube. The faces are the flat surfaces that make up the outside of a polyhedron. So this cube has square faces. Any of these flat surfaces are a face. Edges on a polyhedron are the lines between two faces where two faces connect. So this is an edge of this cube. This is also an edge. And the vertices of a polyhedron are the corners where the edges meet. So this sharp corner here, this is a vertex. This is another vertex. See if you can count. How many faces, edges, and vertices does a cube have? It might help to find something that is close to cube-shaped near you to help you count. All right, if we count the faces, we see 1, 2, 3, 4, 5, 6 faces. If we count the edges, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 to get 4 plus 4 plus 4 or 12 edges. And if we count the vertices, 1, 2, 3, 4. If I flip it over, 5, 6, 7, 8. So a cube has 6 faces, 12 edges, and 8 vertices. Let's look at some other three-dimensional solids and talk about some that have special categories and special names. So the cube that we just saw is an example of a rectangular prism. Let's look at some other rectangular prisms. A prism is a shape that has two congruent bases. Remember, congruent means same shape, same size, that are opposite each other and parallel. So this rectangular prism, those two faces are these two squares, here and here. And those two faces that are congruent are connected by other rectangular faces. So this is another example of a rectangular prism. Our cube would also be a rectangular prism. We could have a smaller cube, also a rectangular prism. We could have something more like this that looks sort of tall and skinny. In this case, the two congruent faces that are opposite each other are these small squares, and we have long, skinny rectangles for our other faces, but it's still a rectangular prism. Or this guy, still a rectangular prism. Now, there are prisms that aren't rectangular as well. If the two congruent faces that are opposite each other are triangles, then we get a triangular prism. So this one is a triangular prism. This one is also a triangular prism where we have an obtuse triangle. On the opposite face, another congruent obtuse triangle, and we have some rectangles connecting those faces. Here's a third triangular prism. We could have different shapes of prism based on the shapes of those two opposite faces, sometimes called bases. For example, this is a hexagonal prism, since those two opposite faces that are congruent are both hexagons with 6 sides. Here's another 3-dimensional object. You might more colloquially call this a ball. The mathematical term for a 3-dimensional ball is a sphere. What do you think? Is a sphere a polyhedron? So no, a sphere would not be a polyhedron since it doesn't have any faces. There are no flat surfaces on the entire outside of this sphere. There are other 3-dimensional solids which are also not polyhedra since they have surfaces that aren't flat. For example, a cylinder. A cylinder has 2 circular faces. And the third surface that connects these 2 circular faces is not flat, so this is not a polyhedron. And we could have a taller, skinnier cylinder, still not a polyhedron. If you consider cones, like you might get for an ice cream cone or a snow cone, those are 3-dimensional solids, but also not polyhedra. The final classification of polyhedra that we are going to be concerned with today are pyramids. So think the Great Pyramids in Egypt. So here's a pyramid. This is a square pyramid because its base, or the side it sits on, if I set it down on my hand in the orientation I would expect it to be if it was one of the pyramids in Egypt, its base is square. And then it has triangular faces that all meet at one point at the top, called the apex. These two are also pyramids, but they're triangular pyramids since their bases are triangles. Now it's time for you to get some practice with these new ideas. See you next time on Dr. G's Technique of the Week.